Hello. So it's Wednesday, the 10th of February, and this is your third maths lesson of the week. And today we are moving on to a new unit of learning. We are going to start looking at statistics. We'll be looking at different kinds of graph and chart and how we can read data. We'll also be looking a little bit at circles because they help us with a certain type of chart we'll be looking at later on this week. So it should be quite a nice unit, and it's probably going to last us up until the end of the second week, so this will probably be a 2-week unit. Firstly, as usual, we have our starter. So I want to get us warmed up with this starter, so if you can have a look at the questions. Today we're looking at a little bit of money and a little bit more fractions, similar to yesterday. So if you pause it and have a go, and then we'll go through the answers. Amazing, right. So Osman saves 10 pence and 50 pence coins in his money box. He has saved £12.70 money bags. So 32 of the coins in the money box are 10p coins. How many 50p coins are in the box? So to work it out, we use this information that 32 of the coins are 10 pences. So 32 times 10 equals 320. And then we use our money knowledge to know that means £3.20. We then know the rest of them are 50 pence, so we need to know how much is left after we take those 10 pences out, so we can split it into 50 pences. So we do £12.70, the whole amount, take away £3.20, which was our amount of 10 pences, and that leaves us with £9.50. And we can use that to find out how many 50 pence coins are in there. We do 950. It's easier to do it that way. Take the decimal point at 950 divided by 50 is 19. So there are 19 50 pence coins in the box. The second one, the table shows the number of loaves of bread sold in a shop each week in February. So first week, 480 loaves sold. Second week, 400 loaves sold. Third week, 70 loaves sold. Fourth week, 250 loaves sold. Which week did the shop sell 1/3 of the total number of loaves of bread sold in February? So that word total should instantly trigger, we need some adding. And then we know we're selling 1/3, so we're probably going to be doing some dividing as well. So the total, you just add up the 4 weeks amounts. So 480, 470, 250 gives you 1,200. And then we want 1/3, so we divide it by 3. So 1,200 divided by 3 is 400. We then times it by 1, but we don't need to write that stage. And then, funnily enough, 400 is one of our options here. So it said, which week did the shop sell? So it was the second week. That's how we solved that one. So today's learning intention is to be able to read and interpret line graphs. Now, I'm sure you've seen line graphs before. Hopefully in year 4 and 5, you went quite in depth with them. So this should hopefully be a bit of a refresher. We're going over, we'll answer some questions on them, just so we've got this knowledge in the back of our heads for end of year 6, moving into year 7. Our star words today: graph, line graph, axis, label, and data. All parts we're going to talk about. So today we're going to look at line graphs and what they are. So I just want you to take a few seconds and have a think, what is a line graph? I'm going to give you an awkwardly long silence to think about it. Well, I can't bear the silence any longer, so we shall carry on. So what is a line graph? A line graph is a graph that uses line segments, parts of lines, to connect data points and show changes in data over time. So we mark our data and then we join it with lines, basically. So here are some line graphs. Hopefully you are recognizing them. So we talked earlier about axes. Okay, so we have our x-axis here, which goes horizontally along the way. You might remember the old along the corridor up the stairs. So that's your along the corridor. And then we have our y-axis here, which goes vertically up and down. We have intervals. We know whereabouts our data should go. So you choose these intervals. And then we have labels for each of the axes. So this is times in minutes. And this is distance traveled in kilometers for this one. And you can see each of the data points is marked by an X here. So they're marked each part of the data. And then you start down at 0 and you work your way up on this graph because it's time in minutes. It's starting at 0 minutes, so you'll have traveled nowhere. So it's moving up that way. We join each data point until we reach here. This one doesn't start at 0. So we've got length of shadow in centimeters. So if you look at the y-axis, we've only got 100 and 200 intervals. We've got lots of intervals between, but they're unlabeled. And we've got the time. So here, if you think about it, at 9 in the morning, there would be longer shadows because the sun's not at its highest. And then it's gradually going to get smaller as the sun moves to its highest. And then it's going to go down. The length of shadows going to get bigger again because the sun's going down. All of the data points are marked vectors and joined with lines, straight lines. Perfect. So here is another graph, and it shows the distance that Larry and Barry walked in an afternoon. They started at 1:45 p.m. and they had 2 breaks. So look at it there and see if you can spot the different bits of information I've just talked about. We've got our time at the bottom, so 2 p.m., 3 p.m., 4 p.m., 5 p.m. So time intervals, and there's lines between which are obviously different amounts of time. If they start at 1:45, they start here, you can probably tell what each little rectangle is worth. It's a little jump. And then distance in kilometers goes up in intervals of 2. Okay, so the x-axis goes up in intervals of 1 hour, and the y-axis goes up in intervals of 2 kilometers. So we've read the axes, the line is there, so now we can start thinking about the different parts and answering questions about it. So what I want you to do is have a bit of a think. You don't need to note it down, but at what time did Barry and Larry stop for their first break? So have a look at that and see if you can spot where they stopped for their first break. So hopefully we're looking at the line here, and they're constantly moving here because the distance they're traveling is going up, but then the distance traveled stays the same. Now, distance traveled stays the same because they are stationary, they're not moving, so they're having a bit of a break there. Then they continue moving again, and we hit another break. Now, the second part of this, I want you to think how long their second break was. So here we can see their second break was longer than their first. It was 2 of our little intervals across. Now here we worked out, if this is 1:45 and this is 2 p.m, then this is 15 minutes. So here, if it's 2 of them, it's 2 lots of 15. 2 lots of 15 is 30. So it's 30 minutes for their second break, or half an hour. We can also work out how far they traveled at certain times, or what time it was when they traveled that amount. So what was the time after they walked 7 kilometers? What we have to do is we have to visualize a line coming from the information we're given, 7 kilometers, which is going to be halfway between 6 and 8, and we draw it so it meets a straight line, so it meets our line graph. Where it meets, we stop. Then this word perpendicular has to got a right angle to it. Okay, it's almost like a corner of a square. It has to meet and go directly 90 degrees from it. So we've come across and met the line, and we draw a perpendicular line that comes straight down and hits here. And that helps us to tell what time it was when they'd walked 7 kilometers, because 7 kilometers hit the line, and then we take it directly down at that time, 3 p.m, 3:15, 3:30. So 3:30 p.m. when they'd walked 7 kilometers. And we did that by using the information we're given, drawing a line across, and then the perpendicular. So, opposite way. How far had Barry and Larry walked at 4 p.m? We use what we've got, 4 p.m, and we draw a line straight up to meet the line graph. We then draw a perpendicular line across, directly across, and as you can see, it's directly between 10 and 8, so it's 9 kilometers. So at 4 p.m, they had walked 9 kilometers. So it's all about drawing your perpendicular lines to help. You don't have to draw them. You can visualize it. You can follow it up and do it. Sometimes I won't draw them. It's completely up to you. So what I'd like you to do now is log on to Mathletics and complete your assigned line graph activity. Give it a go using some of the stuff we've just talked about, and then come back when we've got a problem-solving style question to finish off. So let's move on. So here is our question. Now I'm going to have to, I'll read you the top bit, and I'm going to scroll down a tiny bit so you can see the bottom bit of a question. So I don't want to make it much smaller. Eva has created a graph to track the growth of a plant in her house. So it starts The y-axis is height in centimeters, and the date is at the bottom. The dates of July. Okay, so it starts at the 1st and it goes up in jumps of 2 days. So I want you to complete this in your home learning books, thinking about what we talked about. So Eva thinks these 3 things. She's recorded the following facts. So A, on the 9th of July, the plant was about 9 centimeters tall. So you've been given a date. I'd use your perpendicular method to see if it hits 9 centimeters. B, between the 11th and the 19th of July, the plant grew about 5 centimeters. So did the height change by about 5 centimeters? And C, at the end of the month, the plant was twice as tall as it had been on the 13th. So again, perpendicular method. You've been given the 13th, then find out how tall it was. Is that at the end of the month doubled? So I want you to spot and correct Eva's mistakes. So for A, B, and C in your home learning books, if they're incorrect, correct them and tell me how we do them correctly. And if they are correct, just tell me that Eva got that one right. So off you go and have a go at that one, and then we will go through answers. Right, let's go through the answers. Now, hopefully it won't be too small. There we go. So the first one, A, we draw perpendicular lines. On the 9th of July, the plant was about 9 centimeters tall. So I find the 9th, this red line here, and draw it up to meet my line, and then draw across. Oh, and it looks, it's between 5 and 10. So it's not near 10, which I'd expect for 9. It's between 5 and 10, so it's probably about 7.5 or 7 or 8 centimeters. So it's not 9, so she's incorrect. B, between the 11th and the 19th of July, the plant grew about 5 centimeters. So I do the 11th, and I was probably about 9 or 10. The 19th, it goes up to about 15. So yeah, if we say 10 to 15, she's absolutely correct. It grew about 5 centimeters. For C, at the end of the month, the plant was twice as tall as it had been on the 13th. So on the 13th, it was 10 centimeters. On the 31st, for last day of the month, it was about 27.5, 28 centimeters. Let's say 28. So it was 10, and then it's 28. We're saying it's twice as tall. Well, double 10 is 20, which is nowhere near the 28, so it's more than twice as tall. Actually, if we said the 17th or the 18th, would have been more accurate to be twice as tall. But she, as long as you told me that she was wrong, and it was not doubled in height. So that was using our graphs in a problem-solving context. Well done. Now to finish the session, as usual, on to TT Rockstars, get some of that practice done, please. And then back tomorrow to continue our learning about statistics. Bye-bye now.